This is the Menai Suspension Bridge, designed and built by Thomas Telford in 1826. How did a simple Scottish stonemason come to build this fabulous work of engineering? Telford's work in improving the internal communication system of this country helped make the Industrial Revolution possible. He provided the means for transportation of men, machines and raw materials. No wonder his friend the poet Southey called him Pontifex Maximus, the Colossus of roads. The Menai Bridge was the crowning glory of Telford's London to Holyhead Road, the link to Dublin. Nothing in the world had ever been made on this scale before. An iron bridge of suspended chains which weighed over 2,000 tonnes and was made up of over 33,000 pieces. The bridge's full length is 521 metres and the total length between the spans 176 metres. A beautiful piece of work in iron. A standardised Telford gate design to be found all over his roads. Looks almost Art Deco, except it's 1820, not 1920. What fired Telford's ambition to create this incredible structure? The answer lies in his specification for this wrought iron suspension bridge. The iron is to be best quality Shropshire iron. The world's first iron bridge had been constructed only 47 years before the Menai over the River Severn in Shropshire, the heart of the iron industry. There aren't many places in the world where you can say, this is where it all began. However, this is where it all began. It's very strange in here because this, Abraham Darby's furnace, has been enshrined in this building. You can hear how echo it is. And this casting sand has been raked into some kind of Zen garden. And we've got a sort of sparkly pig iron effect here, so it's all a bit weird. And it feels like we're on some perpetual school trip, visiting a shrine, which of course it is. Because in 1707, Abraham Darby got a patent for a new method of casting pot-bellied cooking pots, you know, the one that looked like witches' cauldrons, in sand. And in 1709, he moved from Bristol to here. And also in 1709, he did an amazing thing, because he discovered a way of smelting iron with coke. He'd worked in the malt industry and he knew the possibilities of using coke, but at low temperatures. And he tried to find a way of replacing charcoal with coke. And in 1709, he succeeded.
This now is a beautifully wooded gorge. But in 1709, it would have looked completely different, because these blast furnaces had an insatiable demand for charcoal.
What Darby did was he removed the ironmaker's reliance on trees and charcoal, and he opened up the limitless possibilities of the coal fields. He freed the iron industry, and he truly was the father of the Industrial Revolution.
The owners of this furnace, Abraham Darby and William Reynolds, established more iron furnaces in the 2-mile stretch of this gorge than anywhere else in Britain.
On the banks of the River Severn lie the peaceful remains of Madeley Ironworks. But in the 18th century, the piles of smouldering coal and ironstone in this area led to it being referred to as Bedlam. The overshot water wheel in there drove 2 huge wood and leather bellows, working alternately, forcing air into the tuyer here, through that small diameter, into the blast furnace. hence the name. I am standing inside an 18th century Shropshire blast furnace. The furnace would have been loaded or charged through the metre-wide mouth in the roof of the furnace. The typical load or burden would have been 6 baskets of iron, 10 baskets of coke and 2 baskets of limestone. The limestone added as a flux to remove the impurities from the iron. The exact amount of iron ore and coke required depended on the experience and skill of the furnace tender down here.
There is a more modern cupola furnace in the area, Blist's Hill furnace, which still uses many of Darby's original charging and casting methods, and I'm going to have a go.
£30-ish. This is a charge for the blast furnace. Contains silica, manganese and limestone. Now the silica and manganese act as a flux and the limestone brings the impurities they remove from the iron to the surface. This is scrap iron, but Darby would have used pig iron, but we haven't got any today. Okay, right, going to charge the furnace. Now some coke, mixed in so it ain't a big modge. And after that, add some air. That's a bit hot, that is. This is exactly like baking a cake. If you get the mixture wrong, it won't set, or in this case, won't flow.
Darby cast his iron in sand, often using mould boxes.
All right, we're outside here, but I'd like you to imagine that this is the foundry floor. Down goes the mould box. It's a 2-part mould box. This is the cope, and here inside is the pattern. Originally that would have been made of wood, but it's made of alley here. French chalk, stop it sticking. This is green sand, originally wet red sand. It's been discoloured by going through with the iron and being burned. Get that into the corners, all nice, look. Very satisfying process. Using a flat ram, get that well down into the mould box. That's the mould box filled. Just level off with a trowel. And now we'll just lay down a bed of sand there. And we're now going to turn the box. 2, 4, right. Now to start on what was the bottom and is now the top. Exactly the same principle for the top. Ventilation. Let gas and steam out. Take the top off. Put that on its side. And we should see the impression there. Right, ready for casting. That is a terrible, terrible mould. I'm going to make a pouring hole now. Metal in here. Air, gas out here. Cast inside. Furnace is now being tapped. The molten iron is going into the crucible, which will then be poured into the casts here on the casting floor.
Telford was amazed at the ingenuity of Coalbrookdale ironmasters like William Reynolds, who faced major transportation problems as many of their hillside furnaces were nowhere near the Severn.
To solve the problem, canals were built. In 1788, Reynolds actively promoted the building of canals in this area. And this particular canal, the Shropshire Tub Boat, was his ingenious idea. This waterway was constructed so that horses like Jack here could haul trains of between 8 and 20 boats. Never mind all that rural. Look at this. This is the last surviving tubboat. It's 5.5 metres long and 2 metres wide. Made of wrought iron most of them were made of wood, which is why there's none of them left. It was designed to carry 5 tons of iron or coal and is basically a 200-year-old containerised system.
Innovative Reynolds still had to get these boats from the canal to the Severn.
This pretty little tugboat canal seems inconsequential until you reach this strange junction here. The tugboats exactly fit in this compartment, where they were hauled onto trolleys which ran on rails. They then came out of the water to begin their descent on this inclined plane to the Severn, down there. This inclined plane, the Hay, was one of 4. Built in 1792, it's 293 metres long. It only takes 3 minutes to lift a boat to a height of 63 metres. It worked on a counterbalance system, with the laden descending boat pulling up an unladen ascending boat, helped by the use of water and a winding engine at the top, up there. Another piece of innovative Shropshire engineering that will be guaranteed to impress the most dour Scottish stonemason.
Imagine the effect all this innovation and ingenuity had on the young Telford.
This is what truly inspired Telford when he came to Shropshire and massively influenced his later work. The ambition and confidence of Abraham Darby III in building this, the world's first metal bridge in 1779, had a huge effect on the development of technology and architecture in the later 18th century. It's bold, daring and brilliant. It's an engineering revolution. This is the first cast iron bridge in the world, and I think it's absolutely fantastic. Darby used cast iron sections. He didn't use rivets. He couldn't. They weren't invented. What he did was he treated the iron like wood, and he made joints. Here's a dovetail here with a bolt going through, and this is a simple tenon held by an iron wedge. A lot has been made of this pseudo wooden iron composite construction as though it's sort of naive. But when you look at the design, which owes a lot to stoneworking methods, the same kind of weight dispersal, when you look at the design, it is anything but naive. It's absolutely fantastic. Look at that single arch. It is majestic. He really wasn't joking.
This bridge was what truly inspired Telford and was to change the course of his career.
Telford came to this area in 1787 as a stonemason to work on the house of the MP for Shrewsbury. What he saw being done here obviously fired his enthusiasm, because in 1788, the following year, he was appointed Surveyor of Public Works for Shropshire, or Salop, as he was also called. That's one of his public buildings there.
Telford's career was being fast-tracked. From stonemason to surveyor, he was really moving and was gaining respect for much of his work, especially his roads.
A very handsome milestone for the A5. Telford's method of construction was roughly this. Very similar to the Roman method of construction, and the A5 was a Roman road, hence our presence here. Right, firstly, and I'm going to make it in this casting box, drain and level off the surface. Secondly, we're going to add some sand for drainage and a base. Now I'm going to add these granite sets, monkey bricks we used to call them, and these go in with the base down and the they're sort of slightly wedge-shaped, so the pointy bit comes up to the top. Telford very anxious to get a good finish because his drainage depending on it. All right then, next we're going to add a layer of walnut-sized stones, and these should go in between these sets. Like that. Work them in between. And if you'll excuse me, I shall now do the time-honoured method. Haven't got the right hobnail boots though. And finally, a smaller layer of gravel. That was designed to compact down with use, so it went right between the smaller stones and finally down through the granite sets. So you have 3 layers there for drainage and strength. And with any luck, we should be able now to see it in cross-section. Keep your fingers crossed. A failure as an experiment, I think, but worth doing nonetheless. The work that Telford did in Shropshire enabled him to go on to build roads, bridges and canals in Great Britain and even parts of Europe.
Telford's already a master road builder, but he wants to work on a new communication system that's still in its infancy, the canals. In the mid-1790s, Telford got his chance, and it was the canals that would allow Telford, a young man with big ideas, the opportunity to truly shine and demonstrate his engineering genius.
This is a 200-year-old experiment, and it's still here. After looking at the Iron Bridge and its use of prefabricated sections, Reynolds and Telford had a go at making their own.
This is an aqueduct over the River Tern on the Shrewsbury Canal, built in 1796. It's dry now, unfortunately.
Look at these joints. It was all a complete leap into the unknown. The best way to make these watertight, Telford found after much experimentation, was to use Welsh flannel with boiled sugar and lead in some weird caulking that is still there. There are similarities between the way this aqueduct is constructed and Darby's Iron Bridge. The way these struts are set into their supports in a woodworking type of way, for example, and some differences. Look at this, pure Telford. These angled joints between plates use gravity in exactly the same way as a stonemason drops the keystone in at the top of an arch. He found new ways to use iron, borrowing from his stoneworking experience. This was a test bed. Telford had the chance, accidentally, because the original stone aqueduct was washed away, to experiment. This was a prototype for his future majestic constructions in iron. Oh! This is the Pont Cysiltau Aqueduct, and it carries the Llangollen Canal over the River Dee. It took 10 years to build, from 1795, and it's the tallest and longest in Great Britain. It's 39 metres high and 305 metres long. It's a giant! The
quality and strengths of cast iron were still not properly understood, so engineers fell back on masonry and carpentry techniques for certain structural details. There was great craftsmanship in the stonework. Thin masonry joints bonded by a mortar made from a mixture of oxblood and lime. Hang on a minute. Oxblood and lime? Telford was fascinated by experimental chemistry, especially when it came to mixtures using lime as a mortar. However, it was the Welsh Druids who had first discovered the strength and durability of that particular strange mixture. The dovetail joints in the base of the iron trough are again sealed with a combination of Welsh flannel, lead and liquid sugar. One of the functions of the canal beyond Pont Cysillte was to act as a navigable feeder, supplying water to the main line. Today, the canal carries over 50 million litres of water every day to supply the needs of southern Cheshire.
Darby's breakthrough in smelting iron with coke let the iron industry boom. Consequently, it needed massively improved transport systems. And Telford, the Scottish stonemason, took up the challenge with a vengeance, proving himself to be an engineering genius.
Near the end of Telford's first canal runs the A5, Telford's major road improvement, the link between Holyhead and London, which has as its crowning glory the Menai Bridge, completing the link between London and Dublin. It just shows what incredibly fertile times these were for ideas and for the interchange of ideas between engineers, entrepreneurs and industrialists. Because this fantastic bridge was built only 47 years after Abraham Darby III built the first metal bridge over the Severn.
Next time, I'll be looking at how Birmingham became Britain's leading manufacturing city. Long live the leisure revolution. Marvellous. Two fantastic facilities side by side. I thoroughly approve.